Good morning, students. Today's session we discuss EER model. In this, we discuss specialization, generalization, constraints on specialization and generalization. Let's see what is ER model. An entity relationship model describes the structure of database with the help of diagram, which is known as entity relationship diagram. An ER model is a design or blueprint of a database. Later, it can be implemented as database. Now, enhanced entity relationship model includes all the modeling concepts of the ER model. In addition, it incorporates the following additional semantic data modeling concepts: specialization, generalization, categorization, aggregation. So now see what is specialization. Specialization is the process of defining a set of subclasses of a superclass. The set of subclasses is based upon some distinguished characteristics of the entities in the superclass. Means, for example, here employee is the superclass. Within that employee we are deriving three subclasses: secretary, engineer, technician. So these are specialization of the employee based upon job type. And one more example: car, truck, bus is a specialization of vehicle based upon vehicle type. Okay. So a superclass may have several specializations. The specialization process allows us to do the following. One is define a set of subclasses of an entity type. Here the entity type is the superclass. One is establish additional specific attributes with each subclass. Means vehicle is the superclass, car, bike is the subclass. Within the subclass, car is the four-wheeler, that is specific attribute of car. Bike is the two-wheeler, that is specific attribute of bike. And establish additional specific relationship types between each subclass and other entity types or other subclasses. Means the car and the bike both are subclasses, the vehicle is the superclass. Here establishing the relationship between the car and bike, the common entity type is fuel. The car will run through petrol as well as the bike will run through petrol. So establishing the relationship between the car and the bike. Next, here see an example of employee specializations. Means here the employee table derives the three kinds of specialization. First, employee table derives three subclasses: secretary, technician and engineer. All these employee table deriving these subclasses with the disjoint partial. Here the secretary and the technician and the engineer having their specific attributes, and along with that they can inherit the attributes from the employee superclass. Okay. Next, the employee again deriving one more subclass, manager. That manager having relationship with other entity, project, so that the manager manages the project. And the employee deriving one more specialization, hourly salaried employee and salaried employee. Okay, hourly employed, salary employed with a disjoint total. Okay, so disjoint total means we are in the diagram we are representing double line with D, that is disjoint total. In the single line with D, that is disjoint partial. Okay, so like that the employee deriving the three specializations. One is secretary, technician, engineer, another is manager, third one is hourly employee, salaried employee. So these three employees are specializations of employee. Next, see the generalization. Generalization is the reverse process of the specialization. Several classes with common features are generalized into a superclass. Means the original classes become its subclasses. In previous example here, the secretary, the technician, the engineer generalized to employee superclass. Like that, the car, the truck generalized to vehicle. We can view car, truck as a specialization of vehicle. Alternatively, we can view vehicle as a generalization of car and truck. Okay, I am repeating. We can view car, truck as a specialization of vehicle. Alternatively, we can view vehicle as a generalization of car and truck. Specialization corresponds to top-down process of conceptual refinement. Generalization corresponds to bottom-up process of conceptual synthesis. So, I am repeating. Specialization is the top-down process. Generalization is the bottom-up process. Now, see the example of generalization. Here, the car and truck are the two entities. Now, the car and truck are generalized to vehicle. Okay. Here, the vehicle is connected to the subclasses car and truck with disjoint total. In coming slides, I give the clarity disjoint total and disjoint partial. Next, generalization and specialization. Diagrammatic notations are sometimes used to distinguish between generalization and specialization. Arrow pointing to the generalized superclass represents generalization. Arrow pointing to the specialized subclass represent a specialization. Okay, I am repeating. Arrow pointing to the generalized superclass represent generalization. Arrow pointing to the specialized subclass represent specialization. We do not use this notation because it is often subjective as to which process is more appropriate for a particular situation. We advocate not drawing any arrows. Now see constraints on specialization and generalization. If we can determine exactly the entities that will become members of each subclass by the condition on the value of some attribute of the superclass, such subclasses are called predicate defined or condition defined subclasses. Means, for example, if employee is the superclass and the technician, engineer, secretary are the subclasses. Now, employee having the one specific attribute, that is job type. Within that job type, I am giving the one value, job type equal to secretary. That is predicating defined. Means within the superclass where attribute I am specifying the condition, then it specifies the only the secretary details. So condition is a constraint that determines subclass members. Here that specifies only the secretary. Next, if all subclasses in a specialization have their membership condition on same attribute of the superclass specialization is called an attribute defined specialization. Means employee having the job type attribute, the job type attribute is related to the all the technician, engineer and secretary. So the job type attribute belongs to these three subclasses, so that it is called membership condition. We are giving that job type. So such attribute is called as defined attribute of the specialization. Example, job type is the defining attribute of the specialization, secretary, technician, engineer of employee. Here see the example. Okay, so employee table deriving three subclasses, secretary, technician, engineer, with the derived attribute job type. Here they are the employee deriving these subclasses with the disjoint partial. Why disjoint partial? Single line with D. Next see user defined. When we don't have a condition determines the membership, the subclass is called user defined. So the membership in a subclass is determined by the database users by applying an operation to add an entity to the subclass, and a membership in the subclass is specified individually for each entity in the superclass by the user. So constraints till now we discussed: predicate defined or condition defined subclass. Next, attribute defined specialization. Next, user defined subclass. Next, we will see along with that we have two more constraints: disjointness constraint, completeness constraint. Now we will discuss the disjoint total, disjoint partial. Okay, let us see what is disjointness constraint. Right, it specifies that the subclass of specialization must be disjoint. An entity can be a member of at most one of the subclass of the specialization, that is specified by D in EER diagram, enhanced entity relationship diagram. So let us take an example for this statement. So here entity type is the superclass. That entity can be a member of at most one of the subclasses of specialization. Okay, means for example, if 100 students are presented in one seminar hall, and that the faculty said who are belongs to the department CSE go to room 1, and who are belongs to the department IT go to room 2. In that case, all the students are went to their respected rooms. That condition is called disjoint total. Okay, I am repeating. If 100 students are available in the seminar hall, then faculty said who are belongs to the department CSE go to room 1, who are belongs to the department IT go to room 2. In that case, all the 100 students are went to their respected rooms. That condition is called disjoint total. If few students are available in that room, that student belongs to some other department, mechanical or ECE department. In such cases, that condition is called disjoint partial. Means he is the student, but he met that superclass attribute, but he has not met the condition. So in that case, we can call as disjoint partial. So if not disjoint, specialization is overlapping. Means that the same entity may be a member of more than one subclass of the specialization, specified by O in EER diagram. Means Coming to an example, for example, 100 peoples are presented in one place. In that, whoever belongs to the business, then raise your hand, and whoever belongs to the employees, then raise your hand. So in that case, the businessman can do the job or employee can do a business. So that the subclasses are overlapping. Here people is the superclass, businessman and employee is the subclasses. So the businessman can be a employee, an employee can be a businessman. In that case, we are called as overlapping. Okay. Next, that is overlapping. Next, completeness constraint. Total specifies that every entity in the superclass must be a member of some subclass in the specialization generalization shown in ER diagram by a double line. So here disjoint total means if all the 100 students or belongs to either CSE or IT department, in that case we call it as disjoint total. The same condition overlapping total also, if the 100 people are belongs to either business, either employee and doing business and employees. In that case, overlapping total, that is shown in ER diagram by double line. Partial allows as an entity not belong to any of the subclass shown in ER diagram by a single line. Means if 100 students, few students are available in seminar hall, means that few students are not belongs to either CSE or IT, thus few students are belongs to some other department, EC or mechanical. In that case, that is disjoint partial. And overlapping partial means if 100 people are presented in one location, if few people belongs to business, few people belongs to employees, and some of them are doing business and employees, but few people are not belongs to these two categories, that people are doing daily wages. In that case, they cannot comes under these two subclasses, businessman subclass and employee subclass. So in that case, they are not comes under these two subclasses. So we can call it as overlapping partial, that is represented in ER diagram by a single line. So disjoint total, disjoint partial, overlapping total, overlapping partial. These are 4 types of specialization and generalization. Now we will see, this is the disjoint partial specialization. Okay, so here employee table is the superclass having the specific attributes. From the employee we are deriving 3 subclasses: secretary, technician, engineer, and with the D single line means partial disjoint. That is, a secretary cannot be a technician and cannot be a engineer, as well as a technician cannot be a secretary and cannot be a engineer. Like that, a engineer cannot be a technician and engineer cannot be a secretary. So that it is called disjoint partial. Next one, overlapping total specialization. Here part is the superclass deriving 2 subclasses, manufactured part, purchased part. Here manufactured part having specific attributes, purchased part having specific attributes. So the purchased parts also definitely be manufactured and the manufactured parts definitely purchased. So that the condition is called overlapping. So they can access all the attributes of the part, manufactured part and purchased part. So this is the overlapping total specialization. Next, see rules that apply to insertion and deletion of specialization. So deleting an entity in the superclass implies that it automatically deleted from all subclasses to which it belongs, and inserting an entity in a superclass implies that an entity is mandatorily inserted in the predicate defined or attribute defined subclasses for which the entity satisfies the defining predicate. And one more possibility insertion, inserting an entity in a superclass of a total specialization implies that an entity is mandatorily inserted in at least one of the subclass of the specialization. Okay, in two cases, first case, if inserting an element in the superclass, that insertion should be mandatorily inserted at all predicated defined or attribute defined subclasses. Next, insertion is doing superclass of total specialization implies that the entity mandatorily inserted at least one of the subclass of the specialization. Next, specialization, generalization hierarchies, lattices and shared subclass. A subclass may itself have further subclasses. Before we seen that manager is the subclass maintaining relationship with the project. So we have project is the subclass. Here main superclass was the employee. So employee is the superclass, manager is the subclass, again subclass, project. So like that a subclass may itself have further subclasses specified on it, forms a hierarchy or lattice. In hierarchy has a constraint that every subclass have only one superclass called single inheritance. This is basically a tree structure. In lattice, a subclass can be subclass of more than one superclass called multiple inheritance. Means a subclass having more than one superclass. Okay, a subclass having more than one superclasses. So that called multiple inheritance. In lattice or hierarchy, a subclass inherits attributes not only of its direct superclass. Okay, a subclass inherits attributes not only of its direct superclass but also all of its predecessor superclasses. A subclass with more than one superclass is called shared subclass, that is called multiple inheritance. So in lattice or hierarchy can have specialization hierarchy or lattice, generalization hierarchy or lattice depending on how they were derived. We just use specialization to stand for the end result of either specialization or generalization. Here see the shared subclass example. Here the engineering manager is the subclass having the three superclasses. One is engineer, manager, salaried employee. So that is shared subclasses. Nothing but multiple inheritance. Here we can observe lattice example of university. Here a person is there with specific attributes. The person is deriving three attributes with overlapping total. One is employee, another one is alumnus, another one is student. Okay, the person is deriving three subclasses with overlapping total. Means overlapping total means a employee may be a alumnus or alumni may be a employee, and these subclasses have their specific attributes. Again, the employee deriving three more subclasses. One is staff, faculty, student, assistant with the disjoint total. Okay, so disjoint total means if staff, faculty, student, assistant both are all belongs to a employee. So that is called disjoint total. So no one person is available there. So that is called disjoint total. So these subclasses having their specific attributes. Now the student assistant again deriving two more subclasses. One is research assistant and teaching assistant with disjoint total. So research assistant having the specific attribute project, teaching assistant having the specific attribute course. Okay. Next, the student subclass deriving disjoint with disjoint total two subclasses, graduate student, undergraduate student with their specific attributes. Okay. So this is the specialization, generalization, lattice example. Okay. Now summarize the today's session. First, we discuss specialization. Specialization is the top-down process. Generalization is the bottom-up process. Constraints on specialization, generalization. One is predicate defined or condition defined specialization. Another one is attribute defined condition. Third one is user defined specialization. Along with that, two constraints, disjointness constraint and completeness constraints. Within that, four possibilities: disjoint total, disjoint partial, overlapping total, overlapping partial. So disjoint total represented with D double lines and overlapping total represented with O double lines. Disjoint partial represented with D single line and overlapping partial represented with O single line. Next, constraints on specialization, generalization, hierarchies means a subclass may have more than one superclass. It is called lattice, that is multiple inheritance. A subclass have only one class, that is single inheritance. Okay. Okay, I hope all of you clear with all these subjects, topics. Thank you.